So in this video we're going to be looking at functions, but we're also going to start the grade 12 curriculum. But the functions, what we're going to do in this unit, I just want to do a quick review of functions before we start expanding our knowledge on it. So we remember from functions some of the key things that we need to remember. So the notation, first of all, f of x is equal to whatever the function is, like x plus 1. You have to also remember when we do have any sort of, like, say, function, we need to remember that every input only has one output. So for every x value, we should have one output y value. So another way of looking at that statement is the vertical line test to see if something is a function. At every time you draw a line down the vertical axis, you should have only one. Doesn't matter where you put this line, it should only go through it one time. What else can we look over? See, this is an example of a function, but you can also have an example where it is not a function. So something like this would not be a function, because you do the test, you have two spots here that would be defined as a function. Let's remember what absolute values are. If you remember, we had, say, the absolute value of -3 is equal to 3, and the absolute value of 3 is also equal to 3. So let's remember, we have to keep that in mind and remember the function for say y equals the absolute value of x. That is going to be, so y equals x is this, but the absolute value will not be negative, it will also be positive. That is our absolute function. We have to remember that. I don't know if we covered these things, but there are some definitions that we can go over. So something called the interval of increase. The interval of increase is basically the interval or intervals, it could be plural, of a function's domain where the y values are getting larger, so moving from left to right. And then we also have, let's just put decrease as well, and that's the exact opposite. I think we did do this. No, we didn't do it. So we can learn also about odd functions. Just brush up on odd functions. An odd function, you have to look at the degree of a function. So y equals x squared is an even function, because let's just put even / odd. This is even because 2 is an even number, and what happens is that y equals x squared will do this. It'll come from up and finish it up, or if you do negative, it'll be like this. It'll come from down and end it down. So it's an even function. An odd function will do something like this. It won't go in the same direction that it came from. So it came from the bottom but ended at top, or you can have So those are things you can look at. Another two things that we should keep in mind are something called a continuous function, and that is basically a function that has no breaks in it, has absolutely no well, this is gonna lead into the next a discontinuity could be like, a discontinuity is a break in the graph. So that point at which it breaks, that's where it's a discontinuity. For example, when a graph will do something like this, if it has this the y-axis as an asymptote, that'll be a discontinuity because it has points for every x value except 0 for x equals 0. So yeah, we do remember our domain and range. Domain is where we can define all of our x values, and range is where we can define all of our y values. So a lot of fun things to go over. If you need a refresher on how to map out graphs, there's tons of videos that I've already done graphing different types of, or sketching graphs of different types of functions. You can just go back there and like see what you want to relearn. What else can we do? We can go over inverse functions quickly. In which, if you remember, if you look at it on a graph, like if you had, say, a function like this, if you drew out an imaginary line like that as y equals x, you would just flip it upon that. So whatever this is, you just flip it like that, in which this would become like that. But if you wanted to do it algebraically, you just swap out the x and y and isolate for y again. So for example, if you took the volume of a sphere, which is volume equals 4 over 3 pi r cubed, if you wanted to find the inverse of this, you would just isolate r. Right now, v is a function of r. So if we swap it out to make it the opposite, we can multiply this by 3. 3v equals 4 pi r terms of functions, it's basically just a review before we get into the actual, when we go into the next chapter, where we start learning about, or we start interpreting functions as rates of change, where we have things such as meters per second, or meters per second, which is meters per second squared. This would be speed, this would be acceleration, all things that are used very heavily in the real world. So